First question is find the derivative of, that is ninth question. You have to find out the derivative of certain things. First one is 2x minus 3 by 4. So in order to find out the derivative of 2x minus 3 by 4, you can just separately find out the derivative of each term. Now from here 2 is a constant, take it out, d by dx of x minus, again d by dx of 3 by 4 means it is a constant, so it will be 0. Sorry, this is not lambda, this is 2. Now 2 into derivative of x is 1, so you are getting 2 as the answer for the derivative of this question. Next one is 5x cube plus 3x minus 1 into x minus 1. So you have a product of 2, so you can use product rule. D by dx of this term will give you 5x cube plus 3x minus 1 into x minus 1. This is d by dx of uv. So you will get x minus 1, or the other way, okay, d by dx of 5x cube plus 3x minus 1 plus 5x cube plus 3x minus 1 into d by dx of the other term. So x minus 1 into derivative of this, again you can separately write this, that is separately do these things. For this, what you will get, d by dx of 5x cube, you can take out 5 and the derivative of x cube will be 5 into derivative of x cube plus, again 3 can be taken out, derivative of x, again minus 1, that is derivative of the constant will give you 0 only, plus 5x cube plus 3x minus 1 into the derivative of x minus 1, derivative of x 1, derivative of 1 0. So here you are getting x minus 1 into 5 into derivative of x cube is 3x square plus 3 into derivative of x 1, derivative of 1 0 plus 5x cube plus 3x minus 1. So here you are getting x minus 1 into 15x square plus 3 plus 5x cube plus 3x minus 1. Multiplying, you will get 15x cube plus 3x minus 15x square minus 3 plus 5x cube plus 3x minus 1. Right? So you have x cube terms too. You can just sum it up. So you will get 20x cube, and here 3x and 3x will give you 6x. 15x square is there. Okay, I will write first 15x square as the descending order of the power, 15x square plus 6x, and here you have minus 4. So this is your final answer. Okay, it in two ways, that is either you can use quotient rule or you can use product rule. How quotient rule? Product rule is you can just see this is one term, this is the other term. So uv, you can use product rule. But if you are changing this, power of x is minus 3. So if you are changing this as 1 by x, this will become x raised to minus 3 is same as 1 by x raised to 3. Now if you are changing like this, the question will become 5 plus 3x by x cube. At that time you can use your quotient rule. But here, since product rule is more easy, we will just continue with product rule. Okay, so we have to find out the derivative of this. Or else one more thing, you can just multiply each term and then also you can continue with it. Okay, so derivative of this will give you x raised to minus 3 into derivative of 5 plus 3x plus 5 plus 3x into derivative of x raised to minus 3, which is equal to x raised to minus 3 into derivative of, again you have two terms, means each of the terms you can differentiate with respect to x. First term is 5, that means it is a constant, and derivative of constant is 0. Second term is 3x, of which 3 is a constant. You can take 3 out, that is d by dx of 3x can be taken as 3 into d by dx of x, and derivative of x with respect to x is 1. So you will get here 3 into 1. Okay. Next term is 5 plus 3x, again constant, and derivative of x raised to minus 3. Again you are using the same thing, nx raised to n minus 1. So you will get minus 3 into x raised to minus 3 minus 1. It should become x raised to minus 4. Okay, so here you have only 3. So 3 into x raised to minus 3 plus, okay, negative sign, 3 x raised to minus 4 into 5 plus 3x. Now we can just multiply them. These two will give you minus 15 x raised to minus 4 minus 9 x raised to, this is minus 4, this is 1. So what the power becomes is minus 3, right? Correct? Now what you will get, both have the same power. This is x raised to minus 3, this is x raised to minus 3, and these two will give you minus 6 x raised to minus 3 minus 15 x raised to minus 4. Or else you can rewrite this as minus 6 by x raised to 3 minus 15 by x raised to 4 also. Okay. This also you can take out the common and write the answer, or else you can stop here. Okay. Again in this problem you have two terms. We will use product rule. So d by dx of this will give you x raised to 5 into derivative of 3 minus 6x raised to minus 9 plus 3 minus 6 x raised to minus 9 into d by dx of x raised to 5. X raised to 5 into derivative of this. Derivative of this will give you derivative of 3, 0, minus 6 into derivative, see, d by dx of minus 6 x raised to minus 9. So I am taking out minus 6 and d by dx of x raised to minus 9. So this will give you minus 6 into minus 9 n x raised to n minus 1, minus 9 minus 1, that is minus 6 into minus 9 will give you plus 54 x raised to minus 10. So I am just writing the answer as 54, this will become positive, 54 x raised to minus 10. Okay, plus 3 minus 6 x raised to minus 9 into the derivative of x raised to 5, again n x raised to n minus 1, 5 into x raised to 5 minus 1 is 4. Okay, so that now we can combine this. You will get 54. Power of x here is 5 into x raised to minus 10 will give you x raised to minus 5. You have to add the power if the base are same. Okay, here base is same, so you can add 5 plus minus 10 will give you minus 5. Again here you will have plus 5x raised to 4 into 3 minus 6x raised to minus 9. Again we will multiply this and getting the term as, this is 15x raised to 4 minus 30x raised to minus, how much you will get, this is 4, this is minus 9, so this is again minus 5. Okay, now here again you can see x raised to minus 5, x raised to minus 5, combine these two will give you 54 and 30, after subtraction will give you 24 x raised to minus 5 plus 15 x raised to 4, or 24 by x raised to 5 plus 15 x raised to 4. This is not compulsory, you can stop here also. Okay. Derivative of, again two terms you have, x raised to minus 4 and 3 minus 4 into x raised to minus 5. So here we will use x raised to minus 4 into d by dx of 3 minus 4 x raised to minus 5 plus 3 minus 4 x raised to minus 5 into derivative of x raised to minus 4. X raised to minus 4 as such. Now derivative of this term. Again you have two terms, derivative of 3 is a constant, so its derivative will be 0, minus 4 into derivative of x raised to minus 5. Okay, I will do it in the next step. Then 3 minus 4 x raised to minus 5 into derivative of, again x raised to minus 4 will give you minus 4 x raised to minus 4 minus 1. So x raised to minus 4 into, this will become, see here the derivative of x raised to minus 5 will give you minus 5 x raised to minus 5 minus 1, that is minus 5 x raised to minus 6. Okay, so it is minus 4 into minus 5 x raised to minus 6 plus 3 minus 4 x raised to minus 5 into, here again you will get minus 4 x raised to minus 5. this will become positive 20, and here you just see the power, here it is minus 4, here it is minus 6. So multiplying, again base is same, you can add the powers, it will give you minus 10. So it is 20x raised to minus 10 minus 4x raised to minus 5 into 3 minus 4x raised to minus 5. So 20x raised to minus 10 minus 12x raised to minus 5, minus into minus, this is plus, 4 into 4 16, x raised to, again base same, powers can be added, will give you minus 10. So here 20, here 16 with the same x term. So you will have the power of x is same, means you can add those two like terms. Okay, so 20 plus 16 will give you 36 x raised to minus 10 minus 12 x raised to minus 5, or 36 by x raised to 10 minus 12 by x raised to 5. Okay. Okay, the question is 2 by x plus 1 minus x square by 3x minus 1. So you have two terms with the quotient form, that is you have a fraction term. So separately you have to use quotient rule. That is d by dx of 2 by x plus 1, and this also you have to use the quotient rule for the second term. So for the first term, d by dx of first term will give you, what is the quotient rule? D by dx of u by v is v into derivative of u minus u into derivative of v divided by v square. So this is what we are going to use now. So here what is the denominator? X plus 1 and numerator is 2. So you will get x plus 1 into derivative of 2 minus, here minus is in between. So this position is very important. First you are writing the denominator term and taking the derivative of numerator. That should not be changed. Okay. Then the second thing is you will alter the position, that is 2 into derivative of the denominator, numerator into derivative of denominator divided by denominator square. This is your first term's derivative, minus, again you have numerator and denominator here, so denominator into derivative of numerator minus numerator into derivative of denominator whole divided by denominator square. Now this term, x plus 1 into derivative of 2, 2 is a constant, so derivative of 2 is 0, minus 2 into derivative of x plus 1, derivative of x 1, derivative of constant 0, so it is 1 plus 0 or 1, okay, divided by x plus 1 the whole square, minus 3x minus 1 into derivative of x square 2x using your nx raised to n minus 1. Now here x square into derivative of this term. Again for first term you have 3x, that means 3 can be taken out and derivative of x is 1. So you will write 3 into 1 minus 1 is a constant, so derivative of 1 is 0 divided by 3x minus 1 the whole square. So here this term will go, here you have only 1, so 2 into 1 is 2, minus 2 you will get in the numerator. So that first term's derivative is minus 2 by x plus 1 the whole square, minus 3x, okay, you can just multiply this. Remember this negative is for the whole term, so in between if you have a negative sign and after taking, if you are taking LCM or what, you have to just be careful for this sign. Okay, here you have 6x square minus 2x minus, what is this term? This term will give you only 3, so it is minus 3x square divided by 3x minus 1 the whole square. So it is minus 2 by x plus 1 the whole square minus these two, again like terms, so you can just simplify them to 6x square minus 3x square will give you 3x square minus 2x divided by 3x minus 1 the whole square. Okay, put a bracket here. So this is what you can do, because in the denominator you don't have anything in common, like, so that you can simplify more. Okay, here it is not visible. Now you can see. For this question, first we will take the function as f of x, that is cos x is the function and you have to find out the derivative using first principle. what will be f of x plus h then? Cos of x plus h. So in order to find out f dash of x, that is derivative of cos x, what is the definition? Limit h tends to 0, f of x plus h minus f of x divided by h. Replacing the values, f of x plus h is cos of, wherever you have x, you have to replace it with x plus h. So it is cos of x plus h minus cos x divided by h. Right? Now you have to use a formula for this numerator. This is in the form cos c minus cos t, or you can say cos a minus cos b. So what is that? Minus 2 cos c minus cos d is minus 2 sin c plus d by 2 sin c minus d by 2, right? Both sign you will have if you have a negative sign here, and if you have positive sign here, both terms will be cos. So here we are using that result, so that this will become minus 2 sin instead of x, c you have x plus h, and instead of d you have x. So what will be c plus d by 2? C plus d will give you 2x plus h by 2 sin c minus d by 2 will give you, x will get cancelled and this will become h by 2 divided by h, right? Now here you have sin h by 2, you can see. So this h together with this 2 will help you to make the limit identity which you can use. So I am just writing like this, 2x plus h by 2 into sin h by 2 by h by 2. Same thing, negative sign is there. Remaining, I have taken this 2 to the denominator part of h so that it doesn't change. Now I am just giving limit to both these terms separately. Limit of the product is equal to product of the limits. So limit h tends to 0 minus sin of, this minus can be taken out from the limit also, okay, by 2 into limit h tends to 0 sin h by 2 by h by 2. So this will give you 1 because limit x tends to 0 sin x by x is 1, right? So using this one you will get this term totally as 1, and you are left with limit h tends to 0 minus sin of 2x plus h by 2 into this is 1. Okay, now you can just replace h with 0 so that it becomes minus sin of 2x plus 0 by 2, which is equal to minus sin 2x by 2. This is inside the angle. Okay, so you can cancel these two and you are getting the derivative of cos x as minus sin x. So the derivative of cos x is minus sin x, and the derivative of sin x into cos x. Okay, so here we will use product rule to find out the derivative of this. So d by dx of this whole term is same as sin x first function into derivative of the second, which is cos x, plus second function into derivative of the first, which is sin x. Okay, now sin x into, already we have discussed right now, that is derivative of cos x is minus sin x, and derivative of sin x is cos x. These two things we are using here. So instead of d by dx of cos x, we can replace it with minus sin x plus cos x into derivative of sin x is cos x. Now what you are getting? This is minus sin into sin square x, plus here cos x into cos x will give you cos square x, that is cos square x minus sin square x, and you have a formula for this. Cos square x minus sin square x is cos 2x. Okay, so the answer is cos 2x. Sec x, actually you have a formula, that is derivative of sec x is sec x tan x. Now how we will find the derivative means you have to find it. Okay, derivative of sec x, I have already given you the formula, sec x tan x. Now we are getting it by simply changing sec x as 1 by cos x, and using the quotient rule. Okay, so now we need to find out what is the derivative of sec x means. We are just taking the derivative of what will be 1 by cos x, right? Now using the quotient rule, denominator into derivative of numerator, which is 1, minus numerator into derivative of denominator divided by denominator square. This is what we will get using quotient rule. Now cos x into derivative of 1 will be 0, minus 1 into derivative of cos x will be, you have already found out, it is minus sin x whole divided by cos square x, right? Now cos x into 0 will give you 0, minus into minus plus sin x divided by cos square x. This is what you are getting, that is sin x by cos square x. Now we are just splitting it into two terms, that is one is 1 by cos x, the other one sin x by cos x, that is denominator has been split as cos x into cos x. One is taken as 1 by cos x, the other one in the denominator of sin x. So this term will give you 1 by cos x is sec x, sin x by cos x is tan x. So the derivative of sec x is sec x tan x. So finding the derivative of this, again you have two terms, d by dx of 5 sec x plus d by dx of 4 cos x. So from here 5 is a constant, take it out. So it becomes 5 into derivative of sec x plus 4 into derivative of cos x. 5 into derivative of sec x, right now we have found out it is sec x tan x. So see, we are directly using here the derivative of sec x, right? Now again you have found out what is the derivative of cos x, which is minus sin x. So you will get here minus 4 sin x. So this is what your answer is. Okay. For cosec x also you have formula, but here what we are doing is we are deriving that formula. For cosec x you have minus cosec x cot x. So for finding out, we will just write cosec as 1 by sin x. Okay. Reciprocal of sin x is cosec x. So derivative of cosec x will give you derivative of 1 by sin x, and using the quotient rule we are going to find out. Denominator, which is sin x, into derivative of numerator, that is 1, minus numerator into derivative of denominator divided by denominator square. Sin x the whole square is same as sin square x. Okay. Now sin x into derivative of 1 constant is 0, minus 1 into derivative of sin x is cos x. Derivative of sin x cos x. So here you are getting this term is 0 minus cos x by sin square x. Now again I am just splitting this sin square x as sin x into sin x, so that I can take one as 1 by sin x and the other sin x as the denominator of cos x, so that this becomes minus 1 by sin x. 1 by sin x is cosec x and cos x by sin x is cot x. So the formula is minus cosec x cot x. It is actually a formula as well as derivative you can use like this. Okay. So the derivative of cosec x is minus cosec x cot x. Derivative of this is again d by dx of 3 cot x plus d by dx of 5 cosec x. Cosec x derivative I have shown you. Now what is derivative of cot x? I will just separately show you and use it here. Okay. Again for derivative of cot x, no, you can just write cot x as cos x by sin x. Okay. So you will have sin x into derivative of numerator d by dx of cos x minus cos x into derivative of sin x divided by denominator square. So sin x into derivative of cos x is minus sin x minus cos x into derivative of sin x is cos x divided by sin square x, right? So you have minus sin x into sin x, sin square x, minus cos x into cos x, cos square x divided by sin square x. Now negative you can take out from both the numerator. terms, you will get sin square x plus cos square x in the numerator and denominator is sin square x. Sin square x plus cos square x is 1. So you are getting this as minus 1 by sin square x, and minus 1 by sin square x is minus cosec square x. So I am just using this answer instead of the derivative of cot x. Okay, so the derivative of cot x is minus cosec square x. So here what will happen? 3 into d by dx of cot x plus 5 into d by dx of cosec x. What is derivative of cot x? Minus cosec square x plus 5 into cosec x. Derivative of cosec x is minus cosec x cot x. So you will have a negative sign here. 5 cosec x cot x. If you want, you can take out cosec x in common also. So this is the answer.